Today I'm going to talk a little bit about organic chemicals. Organic chemistry is a huge topic. You can spend years studying it, and in fact it's the basis of a lot of chemists' careers. Organic chemistry is the study of carbon-containing compounds primarily. So these are molecular compounds, and they're mostly compounds that have a carbon and hydrogen base with some things added on in occasional instances. This is by no means an exhaustive look at organic chemistry. We're just going to take a look at some of the basic, simplest organic chemicals, the functional units that are often found in organic chemicals that are more complicated, and to give you a very basic idea of the naming system that's used for organic chemicals. And this is just to give you the exposure that you'll need for the AP exam, which doesn't include organic chemistry at this point, but does assume that you're somewhat familiar with the basic naming ideas. We'll start out with the very simplest of all organic chemicals, and these are hydrocarbons. Hydrocarbons, like the name sort of implies, contain only carbon and hydrogen. The simplest of the hydrocarbons are alkanes. Alkanes are just a single bonded chain that contains only carbon and hydrogen. So something like this, with hydrogens at the end of all of these sticks, would be the example of an alkane. Now in our generic formulas that we're going to have here, R means a carbon-hydrogen chain of any length. So that means a carbon chain that's making 4 bonds. Every carbon's making 4 bonds, and if it's not bonded to anything else, it'll be bonded to a hydrogen. So our generic formula here is RCR, which implies that it's a chain of any length that contains only single bonds and carbons and hydrogens. The naming system, how do we write the names for these things, or say the names for these? They all end in ane. And they all start with some prefixes that have numerical meaning. So I'm going to use these prefixes right now and then introduce those in a little bit more formally. This is an alkane that's made of a 1-carbon chain, so this is meth. That's how we started out. Meth means 1, and then ane is how we end it. Prop means 3 in the naming system. Here's a carbon chain that's 3 carbons long, and so we'd start it with prop. And because it contains only single bonds, we would end it with ane. This one is 1, 2, 3, 4, 5, 6 carbons long. Hex is the word part that means 6, and because it's only single bonded and contains only hydrogen, we end it with ane, so hexane. You might have heard of like propane before, or butane. That's what these things are, single bonded hydrocarbons. Here are those quantitative naming prefixes. 1 is meth, 2 is eth, 3 is prop, 4 is but, like butane, you probably heard that before. 5 is pent, like the pentagon, 5 sides. Hex, like a hexagon, is 6. Hept is 7. Oct, like an octopus, is 8. Non is 9. Dec, like a decade, is 10. Undec is 11, and dodec is 12. There are other naming prefixes, but we're not going to have to use them. The next type of hydrocarbon, the next simplest, is called alkenes. The generic formula shows a double bond, and so this is just a carbon chain of any length that contains a double bond in it somewhere. The naming system includes ene at the end of the name. So here are some alkenes. This one is 2 carbons long, and the word part for 2 is eth, so this is ethene. And this is a 3 carbon long alkene, so we would call that propene, because prop is the word part for 3. Alkynes. Alkynes have a triple bond in them somewhere. Their ending is ine in our naming system. So here are a couple of alkynes. This is a 2-carbon alkyne, so we would call that ethine. And the non-systematic, the slang name for this, is acetylene, which you might have heard of before. It's in welding torches. This is 1, 2, 3, 4, 5 carbons long, so it would be called pentine. But if you think about it, that triple bond could be in different locations, and that would actually make it a different compound. So we have to specify where that triple bond is, and we would do that by putting a number out in front. So 1 pentine is what we have here because the triple bond is on carbon number 1. Cyclic alkanes. Cycle sort of means wheel. And so these are ring or wheel-shaped structures. They're saturated, which means they're like alkanes. Here's how we name them. We start with cyclo and we end with ane, and in the middle we put the word part that indicates how many carbons are in the ring. So here are a couple of these things. This has 5 carbons, so this would be cyclopentane. And this has 3 carbons, so this would be cyclopropane. Aromatics have an unsaturated ring in there, and they start with cyclo and end with ene. Most aromatics contain what's called a benzene ring. We've seen this when we studied resonance earlier, or delocalized electrons. A benzene ring is a 6-carbon ring that's got alternating double and single bonds. Of course, we know that there's resonance or delocalization, so they're really all 1.5 bonds. But this is often how it's written, or the alternative way is write your hexagon structure and then put a circle in the middle to represent the delocalization. Now we're going to take a look at some organic chemicals that don't contain only carbon and hydrogen. One is called halocarbons. Halocarbons contain a halogen in their structure. So the generic formula is this, Rx, where X is a halogen. And you can have more than one halogen atom attached, and they don't have to be the same halogen. So halocarbons are organic compounds that have at least one halogen attached to them somewhere. Sometimes these are called halogenated alkanes. How do we name them? Well, we name them like the alkane that they're a part of, only we start with fluoro, chloro, bromo, or iodo to indicate which halogen is there. And if there's more than one of these halogens, then we would list them in alphabetical order. Here are a couple of halocarbons, or halocarbons. This is an F structure, basically, ethane, and there's a chlorine attached to it. So we would call this chloroethane. This one down here is a meth structure, because it has a single carbon, and it's got 4 fluorines, so we would call this fluoromethane. But there's 4 of them, so we would actually call it tetrafluoromethane. Tetra meaning 4, so this indicates that there are 4 fluorines attached to it. The naming system that I'm giving you here is just a very bare bones naming system. It gets a lot more complicated as the molecules get more complicated, as you might imagine. But we won't have to deal with that in this class. It's not really an organic chemistry class. Alcohols. Generic formula is ROH. So there's an OH component somewhere on the carbon chain. How do we name it? Well, we name it R, basically name the alkane, and then take the ane part off and end it with anol. So here are a couple of alcohols. This is a 1-carbon chain with an OH group on it, and so this is methanol. This is a 3-carbon chain with an OH group on it, so this is propanol. Now, if you look at this structure, you realize that there are 2 places where this OH could be that would be different. One is on the end and one is in the middle. So this particular propanol is 2-propanol, or in the slang terminology or the non-systematic name, this would be called isopropyl alcohol, which is what rubbing alcohol is. Ethers have this generic structure, ROR prime. So you have 2 separate alkyl groups or carbon chains that are both bonded to the same oxygen. So how do we name it? Well, we name it R, then we name R prime, and then we end with the word ether. And we list the R's in alphabetical order. So here's a couple of ethers. On the left-hand side of this ether, I've got a propyl, and on this side, I've got a methyl. Prop because of 3, meth because of 1. So I would name this in alphabetical order, ethyl, propyl, ether. So we're taking those quantitative word parts and we're just ending them with ill as we name this. Next one, I've got an ethyl group and I got an ethyl group. So I could say ethyl ether, or I could say diethyl ether. Amines. Amines are substituted ammonia. So what I've got here is an alkyl group attached to an NH3. And I should probably just cross out the H part because often the H's are all missing, or at least some of them are missing, where the alkyl groups are attached. So R-amine is how we name it. We name the word part for the hydrocarbon group and then follow with amine. Here are a couple of amines. Here's a single methyl group attached to a ammonia, and so we would call this methylamine. Here are 3 methyl groups attached to a nitrogen in the center, and so we would call this one trimethylamine. Or we could say methyl-methyl-methylamine. A carbonyl group is a carbon double bonded to an oxygen that's part of a chain in an organic compound. In my little generic formula thing that I've got going here, I'm going to call this a B just for short. So one type of compound that contains a carbonyl group is an aldehyde. So the generic formula is RBH. So this is some carbon chain of some length that terminates in a carbonyl group like that. This could be 1 carbon long or it could be 50 carbons long, but it ends in a carbonyl group. How do we name it? Well, we name the R to carbonyl group chain, the RB chain, just like we would an alkane or something, and then we end with anal, not anal, anal. So here's an example of a couple of aldehydes. This is 3 carbons long, so this would be propanal. This one is 1, 2, 3, 4, 5 carbons long, so this would be pentanal. Ketones are very similar to aldehydes, except for the carbonyl group is in the middle of the chain, not at the end. So it's R. Somewhere in the middle there's a double bonded O to one of the C's, and then there's at least one other carbon on the right-hand side. How do we name it? Well, we name this whole chain all the way through like an alkane, and then when we end with anone. But we also are often going to need a number to tell where exactly on the chain is the carbonyl group. Here are a couple of ketones. This one is 1, 2, 3, 4, 5, 6 carbons long. So we would call this hexanone. That's how we end them, anone. And it's on carbon number 1, 2, 3. So 3-hexanone. We always number it so that the carbonyl group would be on the smallest possible carbon number. This one is 1, 2, 3 carbons long, so we would call this propanone. And you could put 2-propanone, but it's redundant because that's the only place it can be and still be a ketone. Carboxylic acids have this formula. You've got a carbon chain that ends with carbonyl group, and then after that, instead of an H, you have an OH group. So we name it by naming this chain like an alkane, and then we end with anoic acid. All right, so here are a couple of these. 1, 2, 3, 4, 5, 6 carbons long. So we would call this hex, and then we end it with anoic acid. Methyl group. Methanoic acid. The last type is called esters. Now, esters have this generic formula. You have R with a carbonyl group and then an O, but instead of an H at the end of it, like we had with carboxylic acids, we have another alkyl group. I'm going to designate that with R prime. How do we name it? Well, we first name this R prime, and then we name this chain, and then we end with anoate. This one actually shouldn't have a H there. It should have a CH3. So this is a methyl. So I start my name out with methyl. And then this is 1, 2, 3, 4 carbons long. So butanoic acid. Well, this gives you just a very basic look at organic chemicals. And actually the last group, the esters, the ketones, the aldehydes, and the carboxylic acids, you probably will not see very often in this class. But it gives you some way of identifying organic compounds if they show up in your life. And this seemed like a good place to put it because we're talking about Lewis structures and covalent compounds right now in this chapter.